So there are lots of reactions out there in the world with positive values of delta G that we want to happen. They require energy either because of the enthalpy or the entropy requirement of them, but they won't happen on their own. When something won't happen on its own, we often couple it or pair it with another reaction that can give it the free energy. Probably the most common example that you'll see in science is the biological example of ATP to ADP. I'm not going to pretend that I know enough biology to explain it well, but the idea is throughout this, in our making and breaking of bonds between our diphosphate and our triphosphate, breaking that guy off, it requires energy to continue or to process. We've got some energy being added and energy being released throughout that process. One that's we're a lot more familiar with is just the idea of recharging rechargeable batteries, whether it's our computer, our phone, or just any old battery. That battery, it's set up so it's favorable that it releases free energy or it gives energy to the source. It's not going to recharge itself. So by plugging it in, we are adding energy to that battery, allowing it to be recharged. Photosynthesis is another great biological example of this same idea. And right here, this is an example that's a little bit more chemical or maybe even geological of trying to purify zinc. So zinc occurs as a mineral bonded with sulfur, but turning zinc sulfide into zinc and pure sulfur requires quite a bit of energy. We could do that by just inputting that energy from maybe a variety of different ways, or we can recognize that sulfur combusting in oxygen to make sulfur dioxide is very, very favorable. So with the Hess's law approach to this, if we take that zinc sulfide and react it with oxygen, it kind of skips this step, which requires a lot of energy, combining them both, getting that sulfur to change right into the sulfur dioxide while freeing our zinc. Overall, that releases energy, or releases free energy, and becomes thermodynamically favorable. So we take something that isn't favorable, we put it with something that is favorable to make an overall favorable process.